This video is to help you remember the rules for significant digits that we went over in class. So this is a guide to helping us know what numbers are significant and what numbers are not when we have so many that we have to deal with. Numbers are significant when they have been given meaning either by measurement or calculation. The number of significant digits that we have and their place tell us if we have confidence in our measurements. So for example, if we're walking from the front door of Norclay to the side door of Maine, it's about 260 feet. That's an estimate. If I actually measure it, it's 264.3 feet. I have confidence in that measurement, and I show that by having a lot of numbers in it that are significant. The 2, the 6, the 4, and the 3. How do you know if a number is significant? There are 5 rules that we're going to follow. The first rule says that all non-zero digits are significant. So again, that's any number that's not 0. So in 24.7 meters, the 2, the 4, and the 7 are all non-zero digits. So we have 3 significant digits in our number. Zeros between non-zero digits are significant. So in our measurement, 207 milliliters, the 2 and the 7 are significant numbers. The 0 between them is then significant because it's between the 2 and the 7. Zeros at the beginning of a measurement are not significant digits. They're what we call placeholders. Their job is to get the numbers to where they really belong. So in 0.004 liters, the job of these zeros is to get this 4 to the thousandths place where it belongs. Only the 4 is measured, and so only the 4 is significant. There's only one significant digit in this number. Zeros at the end of a number are only significant if there is a decimal. So 1.00 meters. This decimal point shows that these zeros were measured. They are accurate, and so they give our measurement a lot of power. 90,000 meters, notice there's no decimal point back here. That means that we think these zeros are estimated. So these zeros are not significant. Only the 9 is. When we use scientific notation, we only use the numbers at the front. So the 4 and the 1 are significant. This times 10 to the 6th indicates placeholder zeros, and placeholder zeros are never significant. There is a flowchart that you'll find on Blackboard that you can download to your Mac or you can print off to help you remember the rules for all of these zeros because they can be so different. Now remember, when it comes to those zeros, you can make them significant or make them not significant. It's all in the power of the decimal point. If you have a measurement like 400 and you don't have a lot of confidence in it, don't put a decimal point back there. Not putting a decimal point shows that it's estimated and that only the 4 is accurate. If you put a decimal place back there, it shows that you put a lot of care and a lot of time into making this measurement, and the 4 and both of the zeros become significant. Those zeros are at the end of a number that has a decimal point. Now, whenever we use numbers that are significant and put them into calculations, we have to account for which numbers are significant and which ones are not. There are rules for multiplying and dividing, and there are rules for addition and subtraction. When we multiply and divide, our answer can have no more significant digits than the measurement with the least number of significant digits. So for example, if I measured 7.55 centimeters that has 3 sig digs and 0.34 centimeters that has 2 sig digs, I'll put that in my calculator. I can't report all of those numbers because my 0.34 centimeters only has 2 sig digs in it. My answer can only have 2 significant digits. So I'm going to start at the beginning of my number, find 2 place values, and round to that second place value. So my answer would be reported as 2.6 centimeters squared. That shows that one of my measurements only had 2 significant digits, and that's all that I can be sure about. If I have 8,432 meters that has 4 significant digits, and 12.5 seconds that has 3 significant digits, my answer can only be reported to 3 significant digits. So I start at the beginning of my number, count 1, 2, 3 place values, and round to that place value. So my answer would be reported as 675 meters per second. Addition and subtraction is a little different. Our answer cannot be accurate than our least accurate measurement, and we decide whether or not a measurement is accurate based on the place value that it ends with. And you're going to find it very helpful to line your numbers up by their decimal points, just like you did when you were first learning to add and subtract numbers with decimal points. So you'll notice that I have these 3 numbers that I'm going to add together. Their decimal points are all lined up. And from there it's easy to see that my first number is accurate to the 10ths place, 1 place after the decimal. My second number is accurate to the 100ths place, 2 places after the decimal. And my third number is accurate to the 10,000ths place. So when I add them all together, I get this big long number. But I'm only going to report to the 10ths place because my least accurate measurement stopped at the 10ths place. So because of that, I'm going to round to my 10th place, and I'm going to report this answer as 184.9 centimeters. These other numbers at the end are not accurate because my least accurate measurement was not accurate to those points. When I subtract, I'm again going to line my decimal points up. It shows that my first number is significant to the 1000ths place. My second number is significant to the 100ths place. So when I add them together, I'm going to round my answer to the 100ths place and report it as 12.32 meters. I hope you find this video helpful. If you have any questions, please feel free to let me know. Thanks for listening.